Okay. So in 4.8, a lot of this is stuff that we've already done before. And we're just doing some more problems. We can do harder ones later, but we're just going to focus on some really basic ones. So I'm starting on number 1A of 4.8. It says, draw a picture, write an equation, and solve it. Okay, that's all we're doing. It does say round to the nearest hundredth, so I will also try and be consistent with that. Okay, so the first one says, find the angle of elevation of a bird in the top of a tree from a point on the ground 100 feet from the base of the tree. All right, draw a triangle. Stop talking. Thank you. The angle of elevation of a bird in the top of a tree that from a point on the ground 100 feet from the base of the tree. So I already was able to label 100 on the ground because that's how far some point on the ground is from the base of the tree. And the bird is 18 feet above the ground. So that's over here. It says find the angle of elevation. Where does that angle of elevation go? What letter does it go with? G. The letter I have up here is just G. And I'm going to write theta. If you like writing X, you can write X. So it's always that angle down here in the bottom corner. Angle of elevation and angle of depression are both down there in that bottom corner. Now is when I want to label O and H. O, H, and A. And then we're going to decide which trig function we're going to use. What are we going to use here?
Oh,
TOA, very good. And so we're going to say tangent of theta equals 18 over 100. How do we go about solving that?
You want to divide or tangent?
We move the tan, but we don't call it dividing by it. We're going to do the inverse of tangent. So we're going to do tan to the -1, inverse tangent, second tan, whatever you want to say, of 18 divided by 100. Now I have my calculator up in its mode menu right now. Make sure you're in degrees. We've been doing a lot in radians, and I'm going to tell you, you're going to have to switch between degrees and radians on that test tomorrow. So just start getting comfortable with it now. When we're talking about these answers, it just makes the most sense to talk in degrees. So we're going to be in the degree mode. Once you're there, click out, and then we'll go second tan 18 divided by 100. I should use a degree, and then you'll know to use degree. And if it doesn't say like if it doesn't have a degree symbol or it has a pi, assume it's radians. When in doubt, you can ask me which mode is this in, but I can't tell you how to switch it once it's the test time. Okay, so my angle is 10.20 degrees. Oh, I don't need feet, just degrees. Okay. If you're feeling good and you want to keep working ahead without me, great. We're just not doing number 3 at the bottom of this page. If not, I'm happy to just keep walking through that. Does that sound good for most of us? All right, I'm just going to keep moving through it. Okay, find the distance from the worm on the ground to the bird in the top of the tree. If the bird's angle of depression to the worm is 24 degrees and the tree is 19 feet tall. Okay, so the worm is on the ground. There's a bird in the top of the tree. The tree is 19 feet tall and the angle of depression is 24. Technically, when I do angle of depression, it's up here. And 24 degrees is up outside of my triangle. But remember that my angle of depression is the same thing as my angle of elevation. So I can also put it down here at that W. And that makes a lot more sense when we start doing O's, A's, and H's. The only other thing I want to do before I identify my opposite adjacent hypotenuse is like, what am I looking for? It says find the distance from the worm on the ground to the bird in the tree. Where am I going to put X to show that I'm going from the worm to the bird? What'd you say? I don't think I've asked the right question. What side is the distance from the worm to the bird? The hypotenuse. I want an X there. I kept getting funny answers. I was like, I don't think I fed this question correctly. Now do your OA's and H's. Now we'll figure out which trig function I'm going to use. So very good. We're gonna do sine of 24 equals 19 over x. Once we get to this problem and we have a degree there, it's easy to know we're in degree mode, but I would just say in general with these word problems, unless it specifically says use radians, then I'm not going to. All right, I'm gonna multiply by x on both sides. I'm gonna divide by 24 or sine of 24. .71 feet. Hope everybody is with me, following along in this stuff. Okay,
Is that ratings?
this is in degrees. 24 is in degrees. You okay? Okay. All right, now I'm gonna jump to the next one. How tall is a flagpole that casts a 23-foot long shadow when the angle of elevation of the sun is 32 degrees? All right, draw my triangle. No, too bad I wouldn't recognize it.
The shadow is on the floor.
Where's the shadow at?
And-
On the bottom, yep. Mhm. The shadow is on the floor. I have to remind myself that sometimes the sun comes down at an angle, but the shadow lays on the floor. And we don't know how tall the flagpole is, so I'm gonna put an X on like my height. And then we know the angle of elevation is 32. Once you have your triangle labeled, do O, A, and H. Decide which trig function you're using. Plug and check. Everybody feeling okay so far?
I don't have to do it in person.
You don't, because you already have the angle, so we know that we're doing tan of 32, so you should just do 23 and then normal tan 32.
Okay.
All right, we're gonna do one more on this page. This one has a little bit of a curveball. It says person places her surveyor's telescope at the top of a tripod 5 feet above the ground. She measures an 8-degree elevation above the horizontal to the top of the tree. That is 120 feet away. How tall is the tree? Okay, so we've got this tree. And I normally don't draw a whole picture out, but I think this will help this round. There's my tree. Pretend it looks good. 120 feet away from this tree, we've got the tripod set up, but it's set up 5 feet above the ground. So my triangle is elevated above the ground a little bit. Here's my tripod with my little telescope on it. And I am currently 5 feet above the ground. That means that I'm still looking for how tall the tree is, bless you. But I'm gonna label the height as X, and I know that at the end, I'm gonna have to add this extra 5 feet that I have taken away by being a little elevated off the ground.
Yeah.
Yep. Bye, Neil. And then I also know that we are 8 degrees of elevation. And I also know we are 120 feet away. All right, now we label O, A, and H, and we decide what we do. And 2 of the last 3 we just did, we're using the same trig function. I don't like to say we always do something because in math, that's not always true, but we often do something similar. So we often are doing tangent when we're doing these kind of functions. Just because that kind of horizontal that hypotenuse distance is kind of hard to measure. It's a lot easier to know or to want the horizontal or the vertical. So get that X all by itself, plug into the calculator. And so I get 16.86 equals X. But am I done?
No.
What do I gotta do? Plus 5. And so I'm really at 21.86 each. All right. We're not gonna do the last one on this page, but we're gonna flip over. We're gonna do 2 more word problems. Should be pretty simple. And then we'll go do some graphing practice for the rest of class. So skip all the way down to number 5 and 6. We will do, if not all, at least some of these ones that we're skipping right now, but I just want to keep it really simple, really basic, just reviewing what we've already done. Okay, so this one says finding a monument height from a point 100 feet from its base, the angle of elevation of the top of the Arch of Septimus Severus in Rome, Italy is 34 degrees, 13 minutes, and 12 seconds. How tall is this monument? When we saw this monument last year, you remember?
Oh, yeah.
When we were in Italy?
Yeah.
Yeah. I have been doing this problem for a long time, and then last year we came back and I was like, oh my God, guys, I've been there. And nobody thought it was that cool, but I thought it was really cool. So we're 100 feet from the base, and it says the angle of elevation is this 34 minutes or 34 degrees, 13 minutes, 12 seconds. Do I put that right in for my angle of elevation, or do I need to do something first? Let's do something, right? Let's make it a decimal degree. Let's make it 34 point something, 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 okay? And we're going to do that by reminding ourselves how we go from minutes and seconds to just a decimal. So if I have 13 minutes, how do I get to degrees? Divide by 60. So it's 1 degree is equal to 60 minutes. I have a hard time remembering if it's multiply or divide. That's why I keep my units and I set up a little conversion chart. So 13 divided by 60 is 216667. And now we need to get our seconds into degrees. So if I have 12 seconds, what do I do to get that into degrees? 3,600 seconds. So 60 times 60. So 12 divided by 3,600 is 0.00333 forever. Now that I have these numbers, how do I figure out what my decimal is? Just add them up. And I'm gonna carry through, I'm not gonna chop it off too soon. I'm gonna carry through some of my zeros and my 3s and 6s. So I get 0.219997. Now all of those round that last one up to a 2. So it's only just gonna be 34.22 degrees. So it's not a huge change from what we had, but it is important to take into account those minutes and those seconds. So now when I go label my picture, I'm going to have 34.22 degrees as my angle. Now it does ask how tall is this monument. So I'm going to put X as that vertical distance. From there, we're going to label O and A and H. And for what feels like the 1 millionth time today, we're doing another tangent. Tangent of 34.22 equals X over 100. Feel good about that? Multiplied by 100 on both sides. Oh, I did one too. And I get 68.01. And that's in feet. All right, one more one. Yep, JT, go ahead. One more. Okay, this one says the angle of depression from the top of the Smoketown Lighthouse is 100. Oh, the Smoketown Lighthouse, 120 feet above the surface of the water to a buoy is 10 degrees. That is a crazy sentence. That's all right. Draw your triangle. Throw my right angle in there. We know the angle of depression is the same thing as the angle of elevation. So I'm going to put 10 degrees down at my angle of elevation. And it says the lighthouse 120 feet above the surface of the water. So that means that 120 is that vertical distance. And it says, how far is the buoy from the lighthouse? I will say that this took me a second earlier. I'm going to label that as that horizontal distance. I don't think it makes a lot of sense to be like, how far is the buoy from the lighthouse and go to the top of the lighthouse, unless it's like, I am at the top of the lighthouse, how far away am I from the buoy? So when in doubt, I'm going to go with that horizontal distance. Label our O's, A's, and H's. Figure out your trig function, plug and chug. And I got 680.55 feet. Is that what you guys got?
You don't do the inverse, no?
Nope, because I still have the angle. You only do the inverse when you have a variable at the angle. If I do tan of X or tan of theta, then I'm gonna do inverse. Just because I am dividing by, this time I actually am dividing by tan. Earlier when you said, oh, we divide by tan, I said not quite, we do the inverse. This time we're actually dividing by tan. This time I have an angle, so I can physically divide, like tan of 10 is a number, so I can physically divide that by both sides. The very first problem that we did today, where it was tan of theta, I can't divide that tangent off because tangent is a function, it's not a number, because I don't have an angle that goes with it. So this tangent by itself, we get rid of it by doing the inverse. Okay. We have about 15 more minutes. What I would love to do is go back to your 4-4 or your 4-5 notes and just do any graphing practice that we want to do. In C period, we looked at J and K on 4.5 and we just changed those to sine and cosines. I think we maybe even looked at H2, but if there's anything in 4-4 or 4-5 that you're like, let's graph that, let's practice it, let's see if we can do it. That's what I'm happy to do right now. Okay. Yep. Yeah, deny. Oh, nothing, okay. Is there anything on those sections that anyone's dying to do? Or should I just do the ones we did in C period? Just do those? Okay, so I'm in 4.5, so your normal notes. And I'm on letter J and K. Which we haven't done those yet, have we, in this class? Great. So this is a good way to practice. So we're just gonna practice graphing these. This one says cosecant. Let's change it. Would you rather do sine or cosine here? Sine? Sure, we'll do sine. Okay, so we'll start, and it doesn't really matter what trig function it is. I could still tell you amplitude period, vertical shift, horizontal shift, and that PS is the same thing as HS if you want to change that. So let's do my amplitude first. Amplitude is 2/5. Then we'll do our period.
This one, can you just change it, because that's what it tells.
Yeah, I will not ask you to graph a cosecant like this. I will ask you to identify cosecant, tan, cotangent. I could ask you to sketch them, but I'm not going to ask you to do all of the crazy transformations. What's my period here going to be? 6 pi. It's going to be 2 pi divided by 1/3, which is the same thing as 6 pi. Yeah.
For the horizontal shift, since there's like nothing outside the parentheses, do we still have to equal to 0?
We're gonna set the parentheses equal to 0, yep. Now, when there's a number outside, usually we don't have to physically set it equal to 0 because it's pretty clear to see that it's just whatever that number is. But when there is a number inside, it's gonna be a little bit tricky, so I'm gonna go off to the side here and do 1/3 x minus pi over 5 equals 0 and solve that. That's what that says, right? Okay. Add that pi over 5 to both sides. And then I divide by 1/3, or you can think of that as timesing by 3. So x is going to equal 3 pi over 5. Is that going to be to the right or to the left? To the right. Mhm. Then I've got my vertical shift. Am I going up or down anything? Up 1, very good. And then you can cross out frequency. I don't do that.
What is that?
It has to do with the period and it just doesn't matter to anything else that we do. So I just didn't bother to learn it or teach it to you guys. Kind of a cop-out answer, but it doesn't matter to me. It doesn't affect how I graph it, so I just don't think it's worth talking about. Okay, now we're gonna start by graphing. I like to do my amplitude first and do any vertical changes. Then I do my horizontal shift and any changes from that. Okay, the perk about this graph, when it's completely blank like this, is I can label whatever I want, wherever I want, right? I can put 2/5 right here, and I can put negative 2/5 right here. I have to move up 1 unit though. So I need to label this. You can label it 1 2/5, or we can make it a mixed or a improper fraction. 2/5 plus 1 is the same thing as 2/5 plus 5/5. So I'm going to move up to 7/5. Now you can kind of do this one of 2 ways. I tend to just, if it's moved up, then I put it up here. 7/5, and if I do negative 2/5 plus 5/5, that gets me 3/5. So then I'm still above the axis. Another thing you can do, and I'll put this back up in a second. No one's asked me to do this yet, but this is something you could do. Instead, you could just label on top your 7/5 and on bottom your 3/5 and just assume that that middle of the graph stays in the middle. I will read your markings to know if that makes sense or not. And since this doesn't say negative 3/5, I know that it's in the right place. You've just shifted your graph up. Okay. I prefer to make it actually look like it's shifted, but you're welcome to do whatever makes the most sense in your brain. Okay.
So I can't do 1 and 2/5 with this one.
You can put 1 and 2/5. As long as I know that that's not 12/5. Okay, now I like to graph my horizontal shift. So I'm going to go right 3 pi over 2 or 3 pi over 5. And this is where the hard part is. We have 5 little tick marks. 1, 2, 3, 4, 5. And I need to know how far apart they are from each other. Do you remember how far apart the tick marks are? What do I do to find that? Divide what by 4? Period. Good. So we're gonna do 6 pi divided by 4, which we did that a minute ago. That's just 3 pi over 2. So I'm gonna add 3 pi over 5 plus 3 pi over 2 to figure out what that next tick mark is, next hash mark. You got to get like denominators though, so the 5 and the 2 can make a 10. So that gives me 6 pi over 10 and 15 pi over 10. And so now I do 6 plus 15, and that gets me 21. 21 pi over 10. What am I going to add next time to get the next tick mark? What'd you say? 3 pi over 2. Or we already have it in like denominators, 15 pi over 10. Good. So 21 plus 15 is 36 pi over 10. 36 plus 15 is 51 pi over 10. And 51 is 66 pi over 10.
It's gonna be different than the rest of them, like denominator.
I don't want to say always because there's never always, but often, yes. Often it is. And that's okay, because technically I could simplify this down, but I just don't want to. And technically I could simplify that down, I just don't want to. So more of them could have a 5 denominator. I just don't make you simplify them so that it looks like they all have the same one and this one has a different one. I saw someone in my last class though change her first one to not just be like 3 pi over 5. She went ahead and just made it 6 pi over 10. So then they all had the same denominator. So if that also makes you happy, feel free to switch that. Okay, now that I have all these marks though, now I'm ready to do my graph. The one other thing I would remember is to put my middle of the graph up here at 1, so I don't like steep too low or go too high when I'm supposed to be staying in the middle of my graph. And now we'll graph our sine curve from here. So I start at the middle, then I go as high as I can, then I go back to the middle, then I go as low as I can, and then I go back to the middle. My line's not perfect, so I'm going to try and keep it in the middle as much as possible. Cool. Should we do the one next to it? Another one to practice? Should we try letter J? Again, I'll change it from tan. Maybe we can make it cosine since we just practiced a sine one. All right, what's going on here? What's my amplitude? 2. What's my period? 4 pi, 2 pi divided by 1/2. Do I have any vertical shift? Nope, you can just write none. Or you could cross it out, I don't really care. And then PS or my HS. We got to set that whole parentheses equal to 0. So I'm going to do 1/2 x minus pi over 6 equals 0. Ooh, it's really close to that one. 1/2 x equals pi over 6. And then divide by 1/2 or times by 2. And so x equals pi over 3. Am I going right or left that pi over 3? Right, very good. All right, so now we go do our amplitude. There's no vertical shift, so once I put my 2 and -2 down, I'm good to go. And again, the beauty of this graph is you could literally label it however you want. You can make your 2 and -2 wherever you want them to be. I don't have to move up or down any, so that's good. My middle of the graph is already there, so I don't have to do a little dashed line for the middle of my graph. Now I'm going to do my right pi over 3. So I'm going to graph my right pi over 3, and I'm going to set up my other tick marks. 2, 3, 4, 5. And now I ask myself, how far is it from pi over 3 to the next tick mark? Just pi, because I'm going to do 4 pi divided by 4, which is pi. So pi over 3 plus pi, which we can think of that as pi over 1. So as we get like denominators, it becomes 3 pi over 3, and pi over 3 plus 3 pi over 3 is 4 pi over 3. What am I going to add to 4 pi over 3 to get the next one? 3 pi over 3. So 7 pi over 3, then 10 pi over 3, then 13 pi over 3. And now we just graph whichever trig function they gave us. Or we decided it's cosine, so we'll graph a cosine. There's no negative or nothing, so we're just gonna graph high, middle, low, middle, high. Ooh, that's kind of funky. Something like that. All right, we still have a few more minutes. I'm happy to graph any more, or if you just need to sit for a second. You have no homework except that study guide is due Friday. So if I were you, I'd probably start it or at least read over it and be like, what questions do I know I'm going to need to go over when I see my teacher? We've got office hours tomorrow. We've got office hours on Friday. Reviews due on Friday when your test is. When's your recourse, you know? Yeah, I'll just be in here, so I'll be ready either way.
Now we go.